electronically using mouse and a circuit diagram. So now, start.
Good afternoon, one and all. We have gathered here today to address about the webinar on virtual labs and its importance in engineering education by our resources, Mr. Sri P. Ravishankar and Mrs. Devian Rizvika. Now, I would like to give a brief introduction about our resources, Mr. P. Ravishankar. Sri P. Ravishankar, an MTech in Mechanical Engineering from IIT Madras with a diploma in Business Management, has 44 years of overall experience working with various employers in manufacturing, IT, and education sectors. P. Ravishankar has worked in the IT industry on developing, deploying, and diffusing competency models that are so critical to the industry. In spite of all the e-learning programs and internships, this has been a bottleneck and is receiving very good attention from academia as well as industry since many decades. Mr. Sri P. Ravishankar has worked on this problem on evolving methods to build competence and ready students and learners to meet the needs of the industry for the last 10 years with some success. India has a good pool of intelligent students. However, the current arrangements in the continuum of academia, industry, and training bodies must be fostered actively and realigned. Mr. P. Ravishankar has been with the IT industry for 17 years, 21 years with the manufacturing industry, and about 5 years with MHRD's Virtual Labs project in IIT Madras. Some of his areas of work include software engineering processes, business process, and IT consulting, research and competency modeling, learning pedagogies, innovation, diffusion and system thinking methods, new product development, and ERP package implementations. His passion is to work in the areas of systems thinking, competency modeling, learning pedagogies, new product development, package implementations. He is currently the program manager of the Virtual Labs IIIT Hyderabad, responsible for outreach and virtual labs in AP and Telangana, hiring, establishing business processes, HR activity, special initiatives like digital classroom training and operation, supporting internship programs. Now I would like to give a brief introduction about our resource, Ms. Devian Rizvika. Ms. Devian Rizvika has been associated with Virtual Labs IIIT Hyderabad as outreach and project engineer for 5 years. She graduated Masters in Information Technology from MSIT IIIT Hyderabad. One of her major contributions to college education has been a key member of the outreach program of the Virtual Labs project IIIT Hyderabad. In this role, she has contributed over 100 Virtual Labs outreach workshops in over 150 engineering colleges in Andhra Pradesh and Telangana, reaching out to over 20,000 students and faculty. These workshops have been done to familiarize and enthusiast students and faculty with the virtual experiments and to tell them the benefits. She has been spearheading the growth of the Nodal Central community of the Virtual Labs IIIT Hyderabad. Ms. Muzika manages the day-to-day operations of the community in the area, covering over 40 Nodal Centers. Among her other important contributions are in the operation and running of student internship programs. She has been an operating member of 3 internship programs run by Virtual Labs IIIT Hyderabad, in which over 300 students participated. Ms. Prithvika is involved in new experiment development and their maintenance, which is one of the core activities of Virtual Labs. In this, she has worked on UI development and usability aspects of experiments and enhancing simulations. She published 2 research papers. One is an SE approach for COCO learning of virtual labs, and second is enhancing virtual labs usage in colleges. Thank you so much. Now I would like to hand over the session to the resources. Thank you.
Thank you, Matrushri Engineering College, and all the faculty and the students for giving me an opportunity to talk to you about virtual labs. I hope you are able to hear me, all of you. Are you able to hear me? Are you able to hear me? Okay.
That's why.
So, shall I proceed with the presentation?
My favorite. మన వీడియో ఆఫ్ చేయండి సార్ మన వీడియో ఆఫ్ చేసి చేయండి
Can I go ahead with the presentation?
Okay, sir.
yes sir
Okay, so I'll just share my screen with you.
Okay, sir.
I'll share my screen with you. Just give me a minute.
Okay, sir. You can go with your presentation, sir.
Yeah, thank you so much.
Thank you, sir.
మన వీడియో ఆఫ్ చేయండి
So I will. So good afternoon, all students and faculty and other participants of this workshop. Yeah, if the students can stop talking and making noise, it will be easier. Can you see my screen?
దాంట్లో నుంచి start చేయండి.
Can you see my screen?
కానీ సార్ ఇక్కడ స్క్రీన్ కరెక్ట్ స్క్రీన్ కరెక్ట్ అవ్వలేదు సార్ కరెక్ట్
Hello?
Sir, your screen is visible.
Okay, thank you. If you can mute the other the participants who are making a lot of noise talking, then it will be more convenient. Okay, thank you. So good afternoon to all the participants of this workshop, all the faculty and the students and any others who are there. So I'm happy that you have given me an opportunity to share the virtual labs project with you about what the virtual labs is and how people are using it and how can you use it. So the entire presentation will be or this session will be in two parts. The first one is I'm going to introduce you to what the virtual labs is, tell you how others are using and what are the experiments that are being used by the other users, and a little about the overall virtual labs project. I'll take about 10 or 15 minutes. Then my colleague Mridvika will actually give you a demo of how to use the virtual labs and tell you what you need to do now. So that will be the second part of it. So I will go ahead and start sharing. See, virtual labs basically means that these are experiments which are available in a virtual form. That means through your computer or through the internet. You can access these experiments through your laptop or through your mobile from anywhere. There is no need for a login and it is free for anybody to use at any number of times. We are basically covering most of the branches of engineering and a little bit about science, some science experiments, etc. I'll share with you what all that is. Essentially, when you're doing virtual labs, the metrics for virtual labs are is called usage. Usage means when one person logs into an experiment or does an experiment or browses an experiment, it is called one usage. So the number of usages that any college is giving is the metric of the extent of usage. So the blocks that you see down below here give you is actually an extract from our outreach portal. The usage which is shown as 45 lakhs here. Then the workshops, that is the online workshops that we do. For example, this one is an online workshop. So where we are directly interacting with you and showing you how to use the virtual labs. We are telling you about virtual labs. So these workshops we have done till now, since the beginning, about 2,359 workshops we have done. And then the number of participants who participated in these workshops is 7,18,000. These are purely these kind of experiments, but I mean these kind of workshops where students have participated. But in reality, you will be using them on your own, either by way of assignments or by way of understanding how experiments are done, how you can play around with them, etc., or because they are included in your curricula, you will be doing them. So those will be captured in a different manner. Those will be captured in a different manner, and this data is not reflecting that. So right now we have total users are more than a crore users across the globe, mostly of course India. Only 10 to 15% is overseas. So this is broadly what it is. So these are virtual experiments available on the net, which you can do. You can go to our site, etc., and how to do that we will show you. Now, this is what I told you. So this is typically how a workshop happens. Like, for example, what you are sitting there. And there's a repository of about 1700 experiments covering 13 domains. That means 13 branches of engineering and science. So I will tell you which are those. So this is a Ministry of Education, Government of India project, and it is built by 11 consortium institutes. That means the leading institutes in India. So we have 6 IITs, then we have IIIT Hyderabad, then we have College of Engineering Pune, Amrita, and NIT Surathkal, etc. So there are about 11 institutes who all together have contributed, and these are the experiments that you will be seeing. So that means each of them has built experiments in their own line of preference or expertise, and these are all available to you on the cloud, and you can access them from anywhere. So this is typically one of the one workshop that you're seeing here, the picture that you're seeing here, the URL, etc. we'll share with you. So why is this virtual experiment relevant to you? See, you are doing today experiments, you're going physically to the lab. Of course, computer science people, for them the lab is also the computer only. You go to a computer lab and then you sit down and do some experiments according to instructions. You write code, etc. But for non-computer science people, electronics, that is ECE for example, or for electrical engineering or mechanical or civil, for them you are actually dealing with equipment. You are actually physically seeing equipment. Electronics people are actually connecting different components of a circuit. They're soldering different parts, and then they're building these different circuits, and then they're learning certain concepts. Whereas in mechanical, for example, or in electrical, for example, you want to measure the brake horsepower of a motor. How do you do that? So you have a motor, and then you have a shaft, and you have a braking facility, and the data which you keep changing the load, and then you keep capturing various parameters, and this is something that you will see. But typically what happens is none of the students are actually able to manipulate anything. So what happens is they are looking at purely the equipment, and they are just collecting data from which is given by the lab assistant or whatever values you're seeing in the meter, and then you're writing a record and giving it. So that is typically what you're doing. But in reality, there will be many doubts in your mind. You would want to say, suppose I change the current input to the motor, what happens? Or suppose I totally break the shaft, what will happen? Or in an electronics experiment, suppose I add two or three more circuits into this, what will be the logic, or how will it work? Those kind of different things. What if I change parameters? What will happen? So this is an important aspect of any learning. Whatever is told to you in class, okay, you are doing it. But suppose something different happens, how do we do it? How do I apply this anywhere? If something is going wrong, how do I understand what is happening? So these are the higher order thinking skills. See, first, so when in the learning process, when you do a virtual experiment, you are actually addressing your higher order thinking skills. That means you are trying to play with parameters and see what is happening. So when this happens, and you can repeat an experiment any number of times, but whereas when you go to physically into a lab, you can't do it as many times as you want because there are so many constraints. The experiment is designed to do certain things, and you do it in teams, or you have lab assistants required to make some changes. All these things are not possible. Changes are not possible in the typical lab environment, whereas in a virtual experiment you can make all these changes as you want. You can keep on playing with them. You can do them any number of times. And moreover, in our virtual lab, what we have done is we have made it a complete unit. Each experiment is a complete unit. What is the learning objective? That means when you do your experiment, at the end of the experiment, what is it that you will learn? That is one thing. Second thing is, what is the theory that is related to this that is available to you? Then what is the procedure that you need to execute in order to do the experiments that is there? And then finally you have the simulation where you actually can play around and do the experiment yourself. Last of all, there is a quiz and a feedback. So each experiment is completely self-contained. It's a learning management system. So what the purpose of virtual labs, every college should have certain number of experiments being done virtually, ideally, because it enhances your learning skills. 30 to 40% of your of additional learning you will get when you do this. And moreover, it is easy for students to do it as in whatever way they would want, because it can be done from anywhere, from your laptop or anywhere. So my suggestion is, or we have been saying, and many universities and colleges are actually including it into the curricula. So I urge the faculty and the management to include it into the curricula and ask the students to do some experiments using virtual labs. Now, all the other things, see, for teaching it's a very good aid, because suppose you want to any experiment, when you're teaching any concept, for example, you're teaching about flux lines, how when the input parameters change, how the flux lines change. If you want to show that, typically you would either have to use a diagram, or you would have to use color chalk or something, or draw different profiles. But if you use virtual experiments when you're teaching about these flux lines, then as you keep changing the inputs, the flux lines will change, the color will change, you can actually see bright things which are happening there. So it's a very easy way to convey a concept. So it's a wonderful teaching aid also. And of course, these are all included in the AICTE model curriculum, and the AICTE wants you to use virtual experiments because the learning is enhanced. So this is as far as the why you should do it. So these are the 11 institutes, the consortium institutes, the 6 IITs, IIIT Hyderabad, NIT, Surat, Kal, etc. These are the colleges which are contributing. These are the institutes which are contributing to various experiments. And this is part of the NMEICT initiative, the Ministry of Education, under which you have got your NPTEL, SWAYAM, and all are also part of this. So NMEICT is the umbrella project, and in that project you have got multiple projects. In that, virtual labs is one, SWAYAM is one, NPTEL is one, all of these are one. So this is also one of those. So you can see here typical workshop that is happening here. You have the person standing there, he's a mentor. See, one of us, or one of the some of the students who have used virtual experiments from our side, they will go there. They used to go there, and then physically students would be asked. This, for example, this workshop would be conducted physically, and our mentors would be there, and while you are doing the experiment, they will guide you, so that when you do about 10 to 15 experiments, you will develop comfort in using it, and you will also get to know where to find which experiment and how do you actually do it, and all that experience you will get. See, anything when you are using, for example, when you first created a Gmail for yourself, there are many things that you didn't know, but as you were using it, you were getting to know more and more. Exactly in the same manner, there's a certain minimum amount of time that you must spend on this initially to be able to get a little comfort and know where to get what. So that is why in this workshop, we want each of you to do about 10 to 15 experiments. When I say do, I mean either you can do, or you can browse and find out and list out 15 experiments that are relevant to you in the feedback form. This is important because please don't think that we are pushing you to do that, but this is important because for anybody to get comfortable with any kind of a new device or a new tool or anything, you have to do it a few times to get comfort. That's exactly what it is. So I'm not use this. So these are the 13 disciplines which are there. You see electronics and communication, mechanical engineering, computer science, civil engineering, electrical engineering, chemical engineering, then chemistry, physics, biotechnology, humanities, etc., etc. So these are the different number of experiments. The one you see on the second block on the right side, where 139 labs is written, it's actually not 139, it's close to 170 labs. So we have In electronics and communication, we have actually 31 labs. It's not 23. It is 31 labs. So mechanical engineering similarly. Computer science has got about 28 or 27. So these are some of the figures have gone up because every year we keep building new experiments. So each of them, these are the institutes who have built them. Like on the left hand side, IIIT Hyderabad, IIT Kharagpur, then Amrita, NIT, IIT Bombay, IIT Guwahati, etc., etc. So this is how the whole thing is. 11 institutes have built it into 13 disciplines. There are roughly about 170 labs. A lab is a subdomain. That means you have, let's say in computer science, you have data structures. Data structures, there are so many different algorithms there in that. You'll have bubble sort, you have merge sort, and so on and so forth. So 10 experiments, 8 to 10 experiments together are put together and they're called a lab. So like that, there are 170 labs, which would mean 170 into 10, roughly about 1700 experiments. Now, I just want to show you how during the COVID part, the usage has gone up substantially. See, before COVID, everybody was looking at it as an additional thing. That means they are doing physical lab experiments, and this they are doing out of their own interest. So the usage is very low, and we were also physically having to go to colleges and do it. But so this red line is the time when there was this lockdown was there. That was 2020 March 25th or something. And then for some time, most of the colleges were shut down, and there was difficulty for colleges to understand how labs can be done, experiments can be done. So, sometime around June, majority of them have accepted to do virtual experiments, and the usage has continuously been going up over the months. So, the top graph, if you see the number of users, which is the violet colored line, you can see the number has grown up substantially. And similarly, a lot of new users have started coming in, which is the blue line at the bottom, the lower line in the top graph. The lower one is the page views, because these are all it's a web application, so we have used tools which will measure the usage of the web pages. So page views instead of usages, these are page views, the number of pages that are being viewed, and the average session duration. See, the usage has gone up substantially during the COVID time, and today we have roughly about 8 crore usages happening, which have been happening since January 2020 to now. And during this time, we have and the usage of these experiments by optimizing the usage. So we are now well within the standard time that a screen should take. It takes roughly about somewhere around 1 to 2 seconds only for the screen to come up. So the screen is also quite fast. So now I just want to share with you the total numbers. I already told you roughly about the usage, non-workshop usage is roughly about 8 crores. And the usage through workshops is only about 45 lakhs in the last, till now. So now this shows you, see, each of these dot in each of these graph in the maps is one nodal center. A nodal center is a college which is interested in using, for example, Matrushri has been a nodal center for quite some time. So you are a college who are interested in using virtual experiments, and therefore we give you, we appoint you as a nodal center. That means you will take up on your own the usage, and then you will. There is a certain target that you need to meet, and then you will also have an opportunity to build new experiments if you are interested. So when you are building new experiments, there are a lot of internship opportunities that come to students, and the college name also will get onto the portal. So that way there are many advantages, but it is up to the students and the faculty if they are interested. So if they're interested, they can talk to us. So if you can see here that in March 2020, just before the COVID lockdown, the map is very sparse with very few dots. So when by the time you came down to October, it increased substantially, and now this is the middle one is July 2021. So you can see the density has gone up. A lot of new centers have come up because a lot of them have started using it. So I just want to show you visually that the usage has substantially gone up because most colleges have realized the benefit of this, and they are using virtual labs. So now these are the top 10 experiment labs that are being used. The most used lab is digital electronics, which is developed by IIT Roorkee. It's got about 8 lakh users, and it has got about 10.8 million. That means 1 crore usages are happening only due to digital electronics. This is the most used one. Then you have basic electronics. Then you have virtual strength of material, analog signals in network labs. Then you got virtual sensor labs, electrical machines, which is what I told you at that time. Software engineering laboratory, then environmental engineering, fluid mechanics, and data structures. You can see here that most people think that virtual experiments means it's mostly for computer science only, but you can see that the computer science one is right down at number 10. That means more than computer science, the other experiments, other domains are using virtual labs. So you can see the clear this thing. So these are the top 10 labs that are being used. And now institute wise, of course, this is also giving you which institute, how many users are there, and what is the average. You can see the average page load time. That means when you click on a button, how quickly does the screen come. So it's varying between 1 and 2, generally 2.5, less than 3. It's more than 3 only in some cases where there's a lot of simulation and a lot of multimedia kind of. This one is there, which is mostly mechanical engineering from Surathkal, mechanical and civil. So now this is a map of the virtual labs that are there and the different course codes and the course names in your curricula. So if you see here, if you in the table, the second column is the course code. Let's say, for example, CS 101 or CS 102. So the course name would be problem solving, or programming, or it's computer programming or something like that. And then you can see the corresponding labs are there. So similarly, we have done this mapping. If you want this mapping, then we can share the link with you. You can take a look at how you can identify different experiments. This particular map was done by NIT Surathkal for NIT Warangal. So this is just a screenshot that I have taken. So these are nodal centers. So you have individual colleges which are nodal centers, and each of these big boxes is one area. So since we are about 11 institutes, each institute looks after the colleges close by. Like, for example, we deal with Andhra and Telangana, and some parts of Tamil Nadu and some parts of Karnataka we deal. Like that, NIT Surathkal deals Kerala, Karnataka, and some parts of Tamil Nadu. Amrita deals with something. So that way, these are all the different nodal centers which are there. The advantage here is that there is more focused usage of virtual labs, and our support is also more easy, and we also can focus on helping you out. So, as I said, the key takeaways. Now, all this was just to familiarize you and to tell you what we are talking about when we say virtual labs. So, one thing is, please remember, whether you like it or not, your higher order thinking skills are the most important skills, and employers look for higher order thinking skills in students. But typically, our labs, the way teaching is happening, etc., the focus for the average student is more on the lower order thinking skills, which is about learning, understanding, and having a comprehension of the topic. But if you want to enhance your skills, you need to go in for things like virtual experiments, where you will start analyzing, and then you will start creating new things, and then you'll be synthesizing different concepts to come up with some new. So your higher order thinking skills are the ones which actually help you in your job, or getting your job, or doing well in your job, etc., or doing well in your other examinations, etc. So we would want you to include this in your curricula. The college, I'm requesting them to include it. JNTU Anantapur has included in their regulations. There are about 8 or 10 other colleges who have included them. So once you do that, either you through your any of your learning management systems, either Google Classrooms or Teams or Moodle or whatever you're using, So it will help you. The college will also get better accreditation points in NBA and NAC. And overall, we are covering somewhere around 38 to 68% of the curricula prescriptions. Experiments are available. That means around 38, around on an average, let's say about 50% of the experiments that you are prescribed in your curricula are available with us, and more will become available. So, Professor Venkatesh Chopella, he is an associate professor in IIIT in computer science. So, he is the PI of the project. That means that he's the head of the project. And anything that you have, you can always share with us through your Nodal Center. Um, I think Dr. Indumati is now the Nodal coordinator in for Matrushini. Earlier, Professor Nukala was he was the Nodal coordinator, and I do hope that your usages will be very much more. So now this is the introduction to the virtual labs. Now I would request my colleague Mridvika to give you a demo and share with you what else needs to be done. Mridvika, I'm logging off. Can you please take over?
Sure, sir. Thank you. Is my voice clear, ma'am? Ma'am,
Pardon?
you're on mute. Sir, is my
I
voice
am.
clear? Okay, sure. So I'll start the session. Good afternoon, everyone. I'm Ridvika.
Ma'am, it's audible, ma'am. It's audible.
Okay, thank you so much, ma'am.
Okay,
So
ma'am. Thank you.
I'm outreach and project engineer here in Virtual Lab. So today, the main intention of uh, the main intention of today learning of this workshop is to learn how to navigate in Virtual Labs. Once you're clear about the process of navigation, you can do it whenever or wherever you want to use, even in your laptops or your mobiles, wherever you want, you can use it. So I'm just going to share my screen first.
You can share your screen, madam.
Yes, sir, I'm sharing it. So whenever you want to do any experiment or see where you can access Virtual Labs experiment, vlab.co.in is the link. So whenever you go to this link, this takes you to this landing page where you can actually see about Virtual Labs. So if you just scroll a bit down, you will see different disciplines here. Different discipline is nothing but different branches that you have in your engineering. So irrespective of your specific branch, you can go and see whatever experiment or whatever lab belong to any different discipline. So like an
Mridvika, is
example,
your screen visible? I can't see it.
I think it is, sir.
So are you able to see the screen?
It's only empty screen, madam. Empty screen.
Uh, One second, sir. I'll just stop and redo it again. So is it visible now, sir?
Now it
Yes,
is
it is.
visible, madam.
Okay.
Right.
So do you want me to do it from the beginning or is it fine? Should I do it from here? So here you can see this vlab.co.in is the link where you can where you need to access for Virtual Labs experiment. So if you just scroll a bit down, you will see different disciplines that are available here. So irrespective of your discipline, you can explore or you can go see the experiments of any discipline that is available here or any branch that is available here. So if you just scroll a bit down, there is a list of participating institutes here. Maybe some students are interested in particular institute like IIT Bombay or IIIT Hyderabad or NIT Surathkal. You can just click on this and see the labs that are developed by the specific institute. So if I've selected on this, so that will show you the labs that are developed by IIIT Hyderabad. So So this is how you can explore or see labs that are related to related discipline wise or the institute wise. So as a part of demo, I'll show you a demonstration of one particular experiment. So once you are clear about the process of navigation, the process of doing any experiment or uh, performing any experiment or any simulation is similar in virtual labs uh, experiment. So I'm just selecting computer science engineering. So whenever you select any discipline, that gives you a list of labs that are available here. So you can select anything that you wish to do and you can do the experiment. So I am selecting data structures one. I am just selecting the quite easy lab so that everybody can understand it in a better way. So whenever you select any lab, that basically gives you an introduction about what that particular selected lab is about. So what is the objective behind this particular lab? And when you click on list of experiments, you can see the list of experiments which are related to the selected lab. So now who are the target audience for this is mentioned here in the target audience section. This particular lab is aligned with any university's curriculum is mentioned here. In this process, in case if you feel like sharing your feedback, you can click on this feedback section and share it. So going back to list of experiments, these are the list of experiments. Whenever you want to see the list of experiment of any selected lab, list of experiments is a place where you can see them. So this is a list of data structures one experiment. So I'm just taking a bubble sort. I'm just selecting the bubble sort. So whenever you select any experiment, basically that gives you an aim. What are you going to learn in this particular experiment is mentioned here in the aim section. When you click on overview, you can go through this video and see the introduction for BubbleSort experiment. Previously, we used to have more reading content, but IIIT Hyderabad has conducted a survey to understand how students are motivated to learn any new concepts. So we understood that most of the students are interested to watch video content rather than the reading content. So we came up with this new approach to include some video content to explain the concept, because we kind of feel like this is kind of more in interaction for student to understand and to learn more in a better way. So you can go through this introduction. I'm just playing for a small bit so that you'll understand how this particular video is included. Okay.
Hello and welcome to the BubbleSort experiment. The aim of this experiment is to understand the BubbleSort algorithm, the basic concept behind it, the actual algorithm, risk optimizations, and its time and space complexity. The experiment is divided into 5 different units.
So basic introduction for BubbleSort is given here in this particular section. So now before going deep into the concept of BubbleSort, we can just take up a. So now we are saying sorting. So what actually sorting is, and what are the types of sorting do we have? So it's kind of just a brush up to your knowledge that you already have. So you can go to the recap section just to brush up your information that you already have. So now before starting any experiment, if you take a pretest, you understand the level of knowledge that you have about this particular bubble sort. Now you can take this pretest just to understand, okay, this is the knowledge I have about bubble sort. So this is kind of a pretest for you before learning any concept. So now going into the bubble sort experiment. So whenever you started to learn about BubbleSort experiment, here it gives you a name. What are you going to learn in this particular BubbleSort is given here. Now going actually into the concept, what is BubbleSort? How BubbleSort is done? You can go through this video that is available here. Along with that, we have also included the theory content where you can actually go through it and see the step by step what actually or how the actual comparisons are happening for one-to-one iterations. So now you understand the concept. So to understand what is the algorithm behind the bubble sort, you can go through this section and you can understand the step by step in what happens in step 1, what happens in step 2. You can go through the actual algorithm behind the bubble sort here. Like if you are not actually really clear going through the content, you can also go through the video which explains you in a more better way. So now we understand the concept and algorithm behind BubbleSort. You can take up a small demo and see how actual BubbleSort is done. You can see how to perform any experiment here in the instruction section. So now there is a speed of the speed minimum and maximum speeds will show you the speed of the comparisons that is happening. So now I've increased the speed a bit. I'm selecting start. Now you can see the comparisons that are happening here, whether the swappings are, whether it is swapping or not. So you can see swap required, whether it is swapping or swap is not required. So now the sorting of this particular array is already done. So here it tells you the how many number of comparisons have happened and how many swaps has been done here. So this is kind of a demo that you can take and understand how actually bubble sort is done. So now you are clear about the concept and algorithm and you saw a demo. You can do some practice by yourself here. So now if you're not clear, you can go through the instructions and see how actually to do the experiment. So now I'm just doing a small bit to just make you understand. So I'm not sure whether the swap is required or not, so I'm just trying to click on swap. So it is giving me an instruction saying that I am trying to swap which is incorrect, so I have to think again. So now maybe it is correct, so I'm just moving to next. So it is suggesting that whatever step you have done is correct. So now I'm just trying to swap it. So it again tells me that whatever you have done is correct. The step that I've gone is correct. So now I'm trying to click on next just to see or understand what is actually happening. So it is suggesting me incorrect, think again, do we need to swap here? So this is kind of an interaction and kind of a hint that this experiment gives you just to make sure you get handy with this particular experiment. So now you did some practice. Now actually you can take up some a specific array and do the bubble sort here. So in case if you need some instructions in how to perform any experiment, you can go through these instructions to understand how actually do you start using or performing this experiment. So now you are done learning with the concept because you have understood the concept, algorithm behind it, you did some practice and you took up an exercise and did the sorting. So now you can actually take up some quiz about bubble sort and see how much you have learned in this bubble sort. So now you understood the concept of bubble sort. Let's see what actually optimized bubble sort is. So basically similarly you have an aim to understand what is optimized bubble sort and what is an optimization technique. So okay, it is saying that optimized bubble sort, but what actually optimization is? So you can go through the video and understand what actually optimized bubble sort is. Similarly, like a bubble sort, you can actually take up a demo and see how actually optimization of the bubble sort is done. In case if you are not clear, you can go through the instructions and perform the simulation. You can see here once the sorting is done, color has been changed just for our understanding. So now we took up a demo. Similarly, you can do some practice like before and take up some exercise and understand. See, it's kind of a very big array, so that this will give you more understanding for you, and it will be easy for you also to understand the concept in a better way. So now you take up the quiz to understand how much you have learnt about optimized bubble sort. So now you know what is bubble sort. and what is optimized bubble sort. The main concept that is actually there is time and space complexity, because there are many other sortings, but which is the best one, or which one is very efficient in which situation. So to understand that, you can go through this analysis section where you can understand the aim, and what are we going to do analysis in this is mentioned in this video. You can go through this video. So now what is actually time and space complexity? That explanation is given here. You can go through the content to understand what actually time and space complexity means.
Ritvika, just give me 1 minute.
Yes, sir.
See, basically, whenever you're understanding this, I'm sure your faculty will be telling you all this, but I'm just giving you a marker here. So, whenever you're looking at any experiment, you should think about what is the context in which it is used. For example, where is data structure, where is sorting necessary. So if you try to understand why sorting is necessary, for example, the simplest example is that when you go to Google and you try to search for something, how does the search happen? So whatever search information is there, that will, how does the system execute it? So it actually needs an ordered list from where it will pick and then it will present to you. So that ordering is done by the use of these algorithms. So among these, if you know this context, then different situations you'll have different rates at which you can do. For example, you want something to be executed fast, its time and space complexity should be looked at. That means how much time is it taking, how much of resources is taking, and all that. So basically, this becomes an important aspect, and that is really what we have included in this, so that you get to understand that all these algorithms, how do they map with each other, and how do they actually get used. So this context, if you keep in mind, your understanding will be much better. So I'm just wanted to give you a marker. So please, Mridvika, go ahead.
Yeah, thank you, sir. So you can take up a array and you can see what the time complexity here. So now, how stable is BubbleSort algorithm? You can go through this content and see what is stable and unstable sort. So you can go through the concept here in a detailed way. So maybe you may or may not have any idea about this deep about this BubbleSort. So this kind of gives you more information rather than the regular BubbleSort that you learn in your normal classroom session. So now you understood, okay, this is what bubble sort is. How is this better when compared to other algorithms, or which is better? You can see when it is compared with the other sorting algorithms here. Uh, sorry. So once you understand the comparison of bubble sort with the other sortings, you can take up a quiz and see, okay, this is how much you have learned about the uh, time and space complexity and how stable bubble sort is. Based on the concepts, you can take up this quiz. So now if you remember, you've taken a pre-test before starting to learn about bubble sort. So now you've gone through the concepts of bubble sort, optimized bubble sort, and time and space complexity of bubble sort. You can take up a post-test. This test will help you to understand how much you have progressed in the concept of bubble sort. This is kind of a booster that gives you, okay, before I was having this kind of knowledge, now I can perform and I'm able to do in a better way. So this is kind of a comparison that you can do it for your understanding. So now you're kind of really interested to learn a bit more about bubble sort. You can go to the further reading section. You can try to learn about the code implementation here, or if you want to test yourself more, you can take up these quizzes and see how much you have learned in this experiment. So in this process of doing or learning this experiment, in case if you feel like, okay, I want to share my experience, or this is kind of really interesting, or any kind of your feedback that you want to share, you can do it in the feedback section. So this is the process of navigation to experiment in virtual labs. Is the process of navigation clear? Like how to select any experiment or how to select any lab, how to go to any lab from one discipline or from any institute. If the process of navigation is clear, I'll go and tell you how to fill the feedback form.
Yes, ma'am.
Okay, sure. So I've actually shared the feedback form with Indu ma'am. So basically this is how feedback form looks like. So this is a 2 pages feedback form. So please make sure you fill your personal details here, your name and on what day you're performing the experiment. This is kind of a personal information to understand when and where or how you have performed this experiment. So now coming here, you can see details of first lab, second lab and third lab. There is no such restriction that you need to do only 3 labs. There are 30 rows available here. You can perform 30 different experiments from Virtual Labs website. So now the name of the lab that we have performed is Data Structures 1. So name of the experiment that we have done is BubbleSort. Does it work? Yes or no? So this works, so I'm writing yes. In case if you feel there is something which is not working, you can write no. And why do you feel it is not working? Like an example, you're expected to get an output of 3, but you're getting 5. So you can write does it work? No. And what is the issue? Expected output is 3, but the output that we have got is 5. So you can give your remarks here in this section. So similarly, now I've done from computer science. Now I'm shifted completely to electronics and communication. You can write basic electronics lab. So now in that, which experiment did you perform? Does it work or not? So irrespective of any discipline or lab, you can write the experiments and name of the labs in a continuous way. So there is no such restriction that you need to. So now you started with computer science, you need to do only computer science experiments. No, there is no such restriction. You can go and you can see all the experiments in different disciplines and you can fill the feedback form here. So now once you're done filling this filling the details of the lab and experiment, if you go to page number 2, you will see 4 questions here. So this is kind of an input to understand is there any improvement or any corrections that has to be done in Virtual Labs website. This is kind of a feedback just to understand are there any enhancement that we have to do or is there anything that is actually creating more impact on students or is there any difficulty that you're going through in the process of doing experiments or you want any changes to make this Virtual Labs website better. You can give all your suggestions, inputs and like compliments, whatever you want, you can share your experience with us. This is kind of an input where we can take from the students and faculty to improve Virtual Labs. Please make sure you put your signature and roll number here. After that, there is a small table here. This is a survey conducted by IIIT Hyderabad to understand at what point of time students are actually motivated to do experiments. So after at the start, like you've seen the demo of BubbleSort now. So how much are you motivated on a scale of 1 to 10? 1 is least and 10 is highest. So now I'll write 5. So after doing 5 experiments, did my interest level increase or drop? So after doing 5 experiments, I felt okay, I'm bit motivated to do or bit interest in doing experiments has increased. So my rating from on the scale of 1 to 10 increases. Similarly, after 10 experiments, did your interest level increase or did it drop? Similarly, after 15 experiments, how do you feel? So we generally request students to do at least 20 experiments to understand at what point of time students are actually motivated to do Virtual Labs experiments. So there is a table box here that is available. So once you're done filling this, please make sure that you write the number of experiments that you have done. It is nothing but there are 30 rows available here. How many experiments did you perform? So we request each and every student to explore 20, minimum of 20 experiments. If you explore 30 experiments, that's really great because that will actually tell you the range of experiments that we have in virtual labs. Once you're clear about the range of experiments that are available here in virtual labs, it will be very easy for you for your future references also. You can suggest your friends and family or your brothers. You can tell them, see, there is something called so and so experiment which will be really useful for you. So this kind of information you can also share with your friends and family. So this particular session will help you to understand the range of experiments we have in virtual labs. Once you are clear about the range that we have, you always don't need to go and explore each and every time. Okay, so now, okay, I want to do data structures. I'll go to computer science engineering and I'll do this experiment. So it will be very easy for you. So we request you to do at least 20 to 30 experiments to understand the range of experiments. So we're asking just to explore. We're not asking you to do each and every experiment because our main intention of this particular session is to tell you the range of experiments. So now you can go through the lab, you can see the experiments that are available here. So that you will understand, okay, this is the set of experiments they have. So once you're clear about this, you can do it from anywhere, wherever you want. So is the process of filling the feedback form clear?
Yes, ma'am.
So now,
See, one thing is, please don't, Ritvika, just give me a second. So,
sure, sir.
the purpose of telling you 15 and 20 experiments and all that is not because we want you to actually sit down and do all those 20 right away, but we want you to browse because, see, typically, according to the study that we have done, and even according to the theory of adoption of anything new, when a new tool is given to anybody, they need some time to develop an opinion and to get a feel that this is good and that they are comfortable at using it. So this is a very it's an established fact. So we have found that somewhere between 8 to 12 experiments is the bare minimum for students to browse on the virtual labs, for them to reach a level where they can develop an interest, or if maybe they are not interested, they may also not be interested. So that is why we are insisting on your browsing, each student browsing 15 to 20 experiments, so that you have given full opportunity for you to develop an opinion and like it or dislike it or whatever. So that is the reason why we are insisting. It is not that you should sit and do all those experiments. Just browsing is adequate. Get familiar, know where what is located, how do I reach, and how do I identify where my experiment is. If I am doing, how do I do? So all these things you will be able to learn. That is why the outcome of this workshop should be 15 to 20 experiments being done, being browsed and listed out there in the feedback form. So that is the outcome of that is what we want from the students, from each of the participants, not only students, each of the participants, even the faculty also, to fill those form with that many number of experiments and then give it to us.
Sure,
The
sir.
idea here is only, yeah.
We'll
So
ask our
this is what I
students.
want.
Hello, sir.
Yes. Yeah, ma'am. Please go ahead.
Sir, definitely we will intimate our students to what is there based on
Yeah.
their interest. We will ask them to search and do that particular experiment, sir. Definitely.
No, they need. I mean, they can do experiments. I'm not saying no. Either doing or browsing. That's what I'm saying.
That's
So
why,
it
sir.
is.
We are having, for example, one lab they are having 20 experiments. What is their interest? According to that, we will intimate them to do go for further through the link.
Okay, ma'am.
Through that,
Okay.
that we will.
Right.
Okay,
Okay,
sir.
Mritvika, please go ahead.
Yes, sir. Thank you, sir. So, in case in this process of exploring or filling the feedback form, in or any other questions you have, we are here to answer. So, in case if you have any questions, you can ask us.
Ma'am, for civil students, they are not having the options of directly connect with that system. So for that type of experiments, how our students, civil and mechanical students can do it?
Sir, can you answer it?
Yeah.
For civil
Now,
and
ma'am,
mechanical.
yeah, so every experiment has got its own simulation. See, you will not be able to, you won't be able to connect anything to your equipment. Everything, see, this experiment which is given here is self-contained. For example, you are doing in fluid mechanics, let us say you're measuring the flow over a weir. So there is an experiment, over an orifice meter or a weir, there is an experiment. So when you're doing it, you are given the option in the simulation itself to adjust the flow of water and to make a measurement of the pressure difference in the YouTube. So what will happen is you are actually manipulating everything on the screen itself. So you don't connect anything to your physical equipment, whether it is mechanical, electrical, or anywhere. It is self-contained, and you are going to do everything on the system only. Is my point? Am I clear?
Yes, sir. And one more clarification. Some of the experiments can we go for other links which is available in IIT Hyderabad? Because already
Yes,
some centers are there. So in that we are having our experiments. Means can we do that?
you can do any experiment, ma'am. The whole thing is open to you. The
Oh,
whole virtual lab repository is open. Anybody
ah,
can use any experiment from any domain and do it as many times as they want. There is no login. There is no cost, so you can do it. Only thing is how you are going to keep track of how many usages are being done is the important thing. So for that you can have you have the feedback form. We will also share with you a Google form, because
oh,
you see, when you're doing in a workshop, it is easy for you to give paper forms and then they fill up and take. But if you're giving them as assignments, or if you're including them in your timetable, it is very difficult for you to give forms and track and all that. It becomes a big stress for you. So we have a Google forms, which will have all the data that is there in the feedback form. So those can be, you can fill them up, and we can make you also a collaborator, the nodal coordinator. If you want anybody else also, you can become a collaborator, and then you can give the assignment and let students do it, and then automatically data will come to you through the Google form system. You can actually, it will give you an Excel sheet output. So that you need to check out, and you should ensure that all the people who have done it, their data is available. So when you are doing that, it will capture automatically, who is doing from when to where, which experiment he is doing, and all that will get captured in the Google form. So that you need to kind of validate it through your nodals, and nodal coordinator should verify it, and then they should sign it and return it to us during the semester, usage during the semester.
okay, sir. Okay, we'll follow that Google Sheet forms.
Yeah, that will be there. But for this particular one, we will be asking you for the hard copies only. Is that right, Ludwika?
Yes,
Okay,
sir.
sir.
Yes, sir.
Yeah.
Is
Okay.
we have already received Satru ma'am.
Okay, ma'am. Okay.
Okay, sir.
Thank you.
Ma'am Rutvika ma'am, is there
Yes,
any
sir.
more?
We are done from our side, ma'am. In case if students or any faculty have any questions, we can go ahead. Otherwise, we can close the session.
Okay. Thank you, ma'am. Thank you, sir. Thank you, Ravi, sir, for your valuable information. Definitely, our students will follow that. And
Yeah.
according to their interest, we are not forcing. We are making the students to learn more about that particular experiment. According to that, we will train and we will get back to you, sir. Thank you,
So,
ma'am.
ma'am,
Rutvika, ma'am.
Thank
please
you.
remember. Hello.
Yes. Yes,
See,
sir.
See, it's not about, at this workshop, it's different. But when you want them to do the experiment, see, why will a student spend time? See, 10% of the students will spend time on understanding more. But the rest of them would like to use their time for whatever is given in their curricula and all that. So, unless you include this as an assignment, or part of the timetable, the students will not be, most of the students will not use it. So the idea here is that if you want to benefit them and give them higher order thinking skills, you have to include it in their curriculum. So if you
Sure.
want them to do over and above that, it will not be possible. So it is not a choice. I mean, this is something that you need to address, ma'am.
No, choice is for experiment, but we are making them to mandatory. They have to follow it because if I give it as choice means if I am not giving at the choice of means all the students will go for single experiment. It should not be like that. So they can do all set of experiments there. That's the thing.
Okay, ma'am. You can work it out yourself on your own. So
We will
that's
give
fine.
assignments. Thank you, sir.
Okay.
Thank you very much for the information.
Welcome.
Ritvika ma'am, thank you, ma'am. Thank you for the
Thank you so much,
information.
ma'am.
Thank you,
Thank
ma'am.
you, ma'am. We are
Thanks.
Thank you.
logging
Thanks,
off now.
everyone. Okay,
Okay,
log
ma'am.
me off.
Thank you.